So this is question number 6 of chapter number 4. You can find it on page number 74 of your book. The question says that a 230 kilovolt 60 hertz three-phase completely transposed overhead line has one aluminium conductor steel reinforced cardinal conductor per phase and flat horizontal phase spacing with 8 meters between adjacent conductors. Determine the inductance in henries per meter and the inductive reactance and the resistance in ohms per kilometer. Now what does completely transpose mean? That the phase are actually transposed after a couple of kilometers. If you look at this diagram, so you can see that phase number 1 is transposed to the middle, and then it goes after a while to the last, and then phase number 2 goes to the last and then goes back to the first position. Phase number 3 starts from the last position, goes to the first position, and then goes to the second position. So in this way, all the phases are actually transposed to keep a good balance. Now, it says that there is a distance of 8 meters between adjacent. Adjacent means the conductors which are beside each other. So the distance between, for example, in this case, between 1 and 2 is 8, and between 2 and 3 is also 8. So what will be the distance between 1 and 3? Of course, it will be 16 meters. So D12 is equal to 8 meters. D23 will be equal to 8 meters also. But D13 will be equal to 16 meters. Now, what about D equivalent? D equivalent can be calculated by using the cube root formula. Cube root of all three distances. So cube root of 8 multiplied by 8 multiplied by 16. You will get the answer of 10.08 meters. Now, because it is a cardinal type of aluminum conductor steel reinforced, you can again find the value of ds, or geometric mean radius, from the table. For cardinal, it is 1.225296 centimeters. You will find the inductance by using this formula: 2 multiplied by 10 to the power minus 7, fixed number, multiplied by natural log of this ratio, D equivalent over ds. Because it is a ratio, you can use either both of them in meters or use both of them of centimeters. The units will cancel each other. So I'm using in centimeters. I just converted the 10.08 meter into centimeters and kept this one, which was already in centimeters. Divide them, take the natural log, and then multiply with 10 to the power minus 7 and multiply it with 2. You will get the final answer to be 1.34 multiplied 10 to the power minus 6, and the unit is Henry per meter. Remember, this formula for inductance with this number that you're using will always have the unit of Henry per meter. Remember this. How do you find the inductance? The inductive reactance, XL, again it is omega times L. Omega already we know that is 2 pi f. Just put the values and put the value of the inductance. You will get the answer to be 5.06 multiplied 10 to the power minus 4 ohms per meter. Still ohms per meter. We did not convert it into kilometer yet. So to convert it into kilometer, just simply write the inductive reactance in ohms per meter and then multiply it with 1000 meter over 1 kilometer, because these are same values. Then of course we can cancel the meter with the meter and we can replace it with a kilometer at the bottom. But of course the number will be multiplied with 1000. So you get 0.506 ohms per kilometer, which is asked in the question. And the resistance again can only be taken from the table. There is no calculation involved. Just look beside cardinal, the last column for cardinal. You will get the resistance to be 0.067247 ohms per kilometer.